Once the program opens, you'll be looking at a page like this, and in the makerspace we have two printers. We've got the M200 Plus, which is sort of the slightly upper spec model. You'll notice it's got a larger screen on it, and it doesn't have the little turn knob that the 200 has. So depending on which one you want to use, you would either select the M200 or the M200 Plus. There's not a lot of difference between them, but it's just good to know which printer you're going to use. So starting with the 200, it then prompts you with the option to add a file, which is our STL file that we've either exported from Fusion 360, or it could be something that we've just downloaded from our website like thingiverse.com. So I've imported my model. In this case with Zortrax, if you hold the center mouse button and push or move the mouse backwards and forwards, it changes your zoom. You can also just use the actual mouse wheel to scroll in and out, so it's quite a good way to do it. If you want to pan around to look at different angles, it's just a left mouse button click. So you notice it looks very similar to Fusion. I can do the same thing, and I can actually click different sections on the box if I want to rotate. It doesn't give me an axis direction like the previous one does, but I can still just click anywhere near the box and I can drag around. So very, very similar to Fusion. And if I go home, it defaults on that sort of 45 down angle. So I can pan around with my left mouse button. I can zoom in if I want to. My right mouse button moves the view. So you'll notice if I start in the home position and I zoom in, I actually need to go down to view my model. So I'll use the right mouse button, click and hold, and I can drag around from that point. So this is my little STL file that I'm going to print. And now if I want to move it around, I can click it and I can either just drag. In this case, if I click and hold, I can move the model anywhere I want. And once I've clicked it, it gives me a whole range of options here. So I've got my move option. I can resize it. So if I wanted to make that thing bigger, I could then just go, let's double the size. And I've now got 200%, so I've got a model twice as big as I had before. So that's my resize. I can rotate it. For example, if it was just facing the wrong way, or more commonly if I had a square object or an object that needed to be printed in a certain orientation. I'll show you an example of that. By default, it has moved it, or it has located it in this orientation, which I can see this red section is not going to print well because it's overhanging. So it would have to print a support the whole way around the model all the way up to be able to print that. It would make much more sense if I just flipped it 180 degrees around using the rotate tool. And now the colors are the axes. So the blue one is just spinning it in this direction, which makes no difference. Green is rotating it in the XY, which is what I want. And in this case, it does have a snap feature. So what I mean by that is I don't have to just guess what's flat. I'll get to a point where it kind of just snaps in, and that's my flat orientation, and it should do that automatically. You can place by face, which means you just say, click the face you want, and it'll put it on the ground. And that'll give you a cleaner option as well to ensure that it is definitely flat. Zortrax does also have an option to auto arrange. So if I click this, it basically stacks them all nice and close together in an order that it thinks will print best. Particularly if you've got lots of small models, this is a great option rather than you manually moving things around all the time. It's a great way to do it. Once I'm happy with the layout of my models, I've got them configured in the right orientation to avoid unnecessary support. I've got them close together, and I'm happy with that. I go down here and I click print settings, and this is where I've got sort of my main features. So the nozzle diameter is really important because that is the size of the hole on the extruder on the 3D printer. So if we use the wrong nozzle size, for example, if I use a nozzle size that's too small for what the printer has, it tries to push more filament through than can fit through the hole, and the printer will jam. If I use a nozzle size that is smaller than what I've got, I won't get enough filament through, and you'll end up with real sort of streaky print, or it ends up looking very spiderwebby because we just don't have enough filament coming through on our model. Layer thickness, this is where the detail comes in. So as I talked about in the earlier video, this is how detailed you want the model to be. Because my little wolf here has some sort of smooth surfaces. It's quite a small model and it's got a lot of detail. If I wanted that in really good quality, I would try and go for a really low, probably like a 0.14, 0.09 is very, very low. But a 0.14 is probably a good layer height or layer thickness to use for this to get nice and curvy shapes. It is going to take longer though. Whereas if I went to something like a 0.29, it's going to be much quicker. I'm going to lose a little bit of that curve detail. I'll start to see sort of the lines and the step effect over curved surfaces. But if I was printing just this cylinder, other than the fact it's got a thread in it, this would be a really good thickness to use because there's no curves to it, it's just straight edges. It would be quite good. The pattern is the infill pattern. So again, as we looked at in the earlier video, I showed you examples of different infill. Doesn't make a lot of difference. It defaults as just lines. You can change it to this sort of honeycomb effect, and you can even have a circle effect as well. Not a lot of difference between it. There's really no, other than maybe if you wanted like if you're making a box or a cube or something like that, you may want to go honeycomb to make it a bit stronger in some dimensions, but the cross-hatch pattern is just as good. And infill density here just changes, you can even see it giving you a preview of the different types, changes how much of the inside of the object is actually solid. So if we go 10%, you can see there's very little in there. As we get thicker, we start to have more and more infill. So this means you use more filament, it'll take longer, but it'll be stronger. So there's always that way up of, do you want a really strong model that's going to take a while? Or if it's just a display item like the wolf, etc., we probably don't need it to be that fill. So if you're just looking for something that's more display than functional strength, anything from 10 to 20 to 30% is good. 10% is completely fine. If you want something like this as part of a threaded bottle rocket, that needs to be quite strong. I'd probably say 50 to 60% is good. And if it was really, really strong, then yeah, you might go all the way up to 90%. It's got to print a near solid object. Once you're happy with all of that, the other thing is to ensure that the material is correct. So ZABS, Z is just the name of the Zortrax brand filament. So we will use a PLA primarily. So you want to locate either the PLA Pro, or if you're using a different filament, there are lots of different types. Ensure that you've selected the right filament. So we are using PLA for this. You can go to other materials, but because we're using this brand, we'll just stick with the PLA. The last thing that you can play around with is in the advanced features, there is a raft option. And basically what that means is when it prints this, it'll print a border around the outside that everything sits on. And it's basically a way of firstly ensuring that if there's any sort of other colors in the printer or anything like that, it purges it, but it also helps it stick to the surface. But this takes a bit longer, and also it means when you peel off your model from the raft underneath it, it's going to affect the surface a little bit. So for this, because the bottom is actually going to be visible, I want that to be nice and smooth. The best way to do that is actually to have it stuck straight to the bed rather than sitting on a raft layer. So you may want to turn this off. It will make it a bit quicker and it saves a bit of filament, so you can turn the raft off. I'll show you what it looks like first with the raft. So if I go to preview, it's going to show me what the print is actually going to look like once it's done. It'll show me exactly how it's going to print. So you can see step by step, this is the raft. This gray section here is the raft. If I go back, turn my raft off, now when I preview, you'll see that it's just printing my models, not the surrounding raft piece. So no raft at all. This is quite good. I actually prefer not to print with a raft. Like I said, it saves time, saves you filament, which is good. And the raft really isn't that necessary. You can see here I do have a bit of support on the dog or the wolf. A lot of this I probably can't change because of the overhang angles. I could potentially get rid of some of that, but Zortrax is pretty good with its supports. And you can see here, this is the preview option. So I can turn off support, but that's only actually turning off in the preview. I'm not actually disabling it. It's just showing me what is going on there. And you can see underneath it's printing a little support here as well because of that gap. Last thing is in the advanced section, you've got the option to alter the supports. So by default, it was at 40%, but this actually works a little bit differently to the other slicing software that I showed you in the previous video, whereas this angle works in the opposite direction. If I increase the angle, it's going to add more support, whereas if I drop it down to, say, 10%, actually let's show you first. If I go 50%, this is what it's going to print, or 50 degrees I should say. It's going to print a lot more support. It's going to support more angles to really ensure that I don't have any issues, but that's a huge amount of support that I've then got to try and pry off of my model. If I drop it back to 10, my angle is only 10 here, it's going to optimize to print a lot less support, which means it's going to be much faster, use a lot less material. And you can see there that's significantly less. And to me, I would say that's probably fine. It's going to print up to here and then print from there and work its way up. And it's convinced that it can support every other piece. So that would be much better. A lot less support to pull off. My model's going to look cleaner because I haven't got all the little bits where I've broken the supports away. And it's just going to be quicker in general. So we're looking here. In this case, it's going to take just under 2 hours to print. And we're going to use 6.8 meters of filament. From here, the Zortrax uses an SD card for printing. So you would take the SD card out of the Zortrax printer, put it in your laptop, and then once you go to export the file, you would save it. You notice it saves it as a Z code file, and that is the Zortrax specific name. So an STL file is just a generic 3D printer image or file. Once you've converted with a slicing software, in this case it changes it to Z code, and that's what you would save on the Zortrax SD card. You take that to the printer, and then I'll show you how to print off the printer with that in the next video.